Software Engineering Radio, episode 142, interview with Kevlin and Klaus from OOP.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast.
Welcome. This is so for those of you who have been at the Tom DeMarco session with Peter Ruschka and at Linda's session, you might, ask yourself, can't I get rid of this guy asking the stupid questions? But this is yet another session that we're going to do together with the SE Radio podcast. So that's why I'm going to ask quite open-ended questions about the topic. And, of course, this will be recorded. And as I said in the sessions before, the original idea of this was that audience, which is you, will be able to ask questions. So it would be helpful if you actually did this. So if you have any a question, just let us know. And we'll also reserve time towards the end for specific questions. And I'll come running to you and give you my mic so you can say something because you don't have another mic in the room. But that should work. So I guess we should get started. And before we do that, before we get started with the topic, I think we should introduce the main act. I'm just the support act. And I guess, who wants to start? Klaus? Kevlin?
I guess I'm listed first. So alphabetically,
okay.
I beat Klaus to it on two fronts. Kevlin Henney. I'm an independent consultant and trainer based in the UK. I have a lot of interest in things like software architecture, programming languages, and development process, stuff like that.
Okay, I'm Klaus Marquardt. I'm working for Jaeger Medical, company building life supporting systems, and I happen to do a lot of architecture and release management and stuff like that, taking care of processes as well.
And for completeness, my name is Markus Völter, and I'm going to ask the questions. So it's about sustainable architecture, so sustainable software architecture, obviously. So maybe we want to start with doing the obvious thing, which is to define first software architecture and then sustainable software architecture. Who wants to give it a shot?
Okay. The idea with this is a rather useful definition of sustainable that we can actually take from the United Nations report, the Brundtland report. Sustainable development, which implies meeting the needs of the present without compromising the ability of future generations to meet their own needs. So very much from the point of view of sustainability, we are talking about creating architectures, software architectures that have this quality, that we are able to effect what we need now successfully, appropriately, without messing it up for the future. So as a counterexample, the first project that I worked on, the first commercial software development that I did after university, there was a project, or the first company, where the changes that were needed for the system took far, far longer than expected. Far, far longer than expected. And the system had originally been written by my boss. It was one of these cases where the boss writes a whole load of code, gets the business, and then suddenly you need more people to look after the code. And I remember my boss saying, it didn't take us this long to do the first version. And you looked at it and you say, yeah, I know, I can see. That's why it's taking so long to do the second version. That is an example of not sustainable. So there is this notion of balancing the present with the future. That doesn't mean we are designing for the future. We are not over-parameterizing. We're not second-guessing the future. But when we work with the present, we are not trying to burn the bridges to the future. So that is really the notion of sustainability that we're focusing on.
Yeah, let's add a bit about software architecture here, because software architecture is not about foreseeing the entire future that the system might see sometime in some other universe. And some software architects think they need to prepare for anything that may come up. And it's a virtue to build systems that are configurable, but it's also a virtue to just build systems that do what we need today. And this is also meant by sustainable, that we do what we need today and not doing what we need tomorrow as well, but not preventing what we might need tomorrow. It's a bit like the approach that the Aborigines in Australia have.
Okay.
So when they leave some place, after a few days, you will not know that they have been there.
Mm-hmm. Okay.
So they leave no footprint. And talking about software architecture, leaving no footprint is not exactly software architecture, but having a minimal footprint. Yeah. Like if you talk about all decisions in the project that you make, all technical decisions, then there's a lot of decisions to make. And I would call these architectural decisions that are hard to change.
So we have that notion there of, there are many different definitions of software architecture. Some of them refer just to the macro structure of a system. The problem is working out what is that macro structure. A more useful one, a number of other people favor, is the idea of decisions that are difficult to change. And the definition from Grady Booch emphasizes this idea of significant decisions. In other words, where significance is defined by cost of change. So for a large class of design decisions, not all of them are going to actually be critical in future. Some of them will be critical and more critical than others.
And that can be on a very detailed level, like the locking protocol for accessing a resource. It's a very detailed thing, but it's still important to get it right globally.
Exactly. So therefore, sometimes small details have very large consequences. So it's not just about the big blocks. There can be very subtle details. And that is partly the challenge. We've seen various problems in the past where people have made what have been considered to be implementation level decisions, even in things like wire level protocols. Oh, we'll make that 16 bits, we'll make that 4 bits, we'll make that 32 bits. And what's happened is that has become not a minor implementation detail, it's actually become a fundamental constraint on the way the system evolved. It's not the big box PowerPoint architecture, but nonetheless it is what we would consider architecture in the sense of significant decisions. So how do we make such significant decisions, a collection of them creates a system? How do we pursue that notion of sustainability?
So is sustainability related to maintainability, evolvability, platform independability, and other abilities?
Yeah, it saves on words. Yeah. It's a sustainable word because we only use one word. Yeah, okay. You had to use lots of words there.
Okay, but that's the idea, right?
Yeah, there's an essence of all of these activities, if you like, all of the activities that result in the continued development, deployment, and lifetime of the system. What are all of those combined? We are interested in the ones that make them sustainable, which may be that maintainability aspect on its own for some systems, but for other systems it may be the evolvability in other ways.
If you talk about sustainable software architecture, let's just phrase that the software architect also needs some sustainability. Because of all the decisions that could become expensive in the future, software architects sometimes have a tendency to micromanage all technical decisions, which is a way to be sure that every engineer really hates you. And this is not a very sustainable position. Yeah. So sustainable software architecture, I think, can only be done by software architects who consider themselves sustainable.
That's a really good point, yeah. So I think, the reason why we have this session is that sustainable software architecture probably isn't trivial. So is the magnitude of the challenge somehow, a function of the project size or the domain, or how can you, classify the problem depending on properties of the system? Or isn't there any such?
I don't think there's one easy answer to that. In terms of complexity, we have a number of different things that can influence it. And in fact, conveniently enough, we drew up a mind map. This was when I was at Klaus's home in Lübeck last year. We sort of said, what do we think about this? And we sort of came up with some ideas, and Klaus jotted down this mind map. Loosely hierarchical, but not perfectly, of various thoughts, because actually there's a whole space of connected ideas. In some cases, what you're looking at will be inherent technical complexity of a system. The inherent technical complexity, as in the software solution itself, is the thing that is the challenge. In other cases, it's the organization that surrounds it. What defines something to be sustainable or not is the way in which the company around it actually tries to develop it. So there's a lot of different issues there. There's impacts of regulation, there's impacts of the scale of the software, even simple software ideas, but lots of them, the sheer mass of millions upon millions of lines of code. Even if every individual thing is somehow simple in its own right, the overall mass is somewhat challenging. So the sustainability, the degree to which you have to apply that idea is definitely influenced by these different aspects of scale. Clearly, if you have a 2 or 3 person project, and all the developers are co-located and you're talking about a web-style release cycle, that is at a very different end of the scale to something that is potentially life or business critical, distributed across multiple sites, across multiple time zones, and has a product cycle that reaches into decades rather than weeks or months. So I don't think there's necessarily a simple answer. It's more like a chart or a list of factors that you can consider and sort of compare against other classes of system.
Well, I think team size is a key issue here. We were talking about making decisions earlier, and actually, as an architect, I don't want to take every decision in the entire system, but what I really want is local decisions by the developers while they do their daily work. On the other hand, I know that local decisions can be really dangerous to the entire system, to the architecture then. And within the team, we need a common sense, a common understanding of which decisions may be hard to change and which not. So, in other words, when to refer to the architect and when not. Mm-hmm. And this is kind of a team culture that must evolve. And the larger the team is, and the faster it is built up, the higher the chances that you do not get it right.
Which relates to a notion in that case that we can see in terms of vision. The vision of a system is, one aspect is the aspect of the design vision, the architecture in that respect. But one other aspect is the shared vision that people have about how the system should continue to be developed. And what is interesting is that we normally talk about team size, and we normally talk about numbers like 9 or 10 as a sort of ideal maximum. But we also see very large-scale software development that is also considered sustainable. And there are a number of open source projects that have demonstrated a very counterintuitive model because of the team size is ridiculously large. It's not co-located, but what binds it together is a shared vision and communication.
And commitment.
And the commitment. There is a sense of personal commitment. So there's that notion that people share this idea, that we care about this in some way that is a little bit deeper than a paycheck. If you are working in a company, to get that same kind of commitment requires a slightly different approach, but clearly people care about their paycheck, but you are looking for something to be built up and a level of understanding that probably takes a little more nurturing, a little more encouragement, and therefore will take a certain amount of time. And as Klaus said, if you have this rapid growth phase and then you split teams up for reasons of so-called efficiency and you scatter them across the globe, it is very unlikely that you will end up with a sustainable software architecture. You will end up with something, but it is unlikely to have these qualities about sustainability. There will be a lot of adversarial us and them kind of notions.
Yeah, their fault.
There's the idea of the architects will if you distribute architecture responsibility, you will end up being polarized at each site. Architects will declare war on each other with their local tribes and their local teams, us against them. But likewise, you can get the other case where you introduce a hierarchical structure, and chief architect is handing down these things, and architect turns into cop and micromanager. So there's the potential for failure is very, very large. But this notion of careful growth of team, along with the careful growth of software, is a good starting point. In other words, a sustainable start, rather than let's do it and then we'll make it sustainable.
So If I were a cynic, I would say we didn't talk about architecture yet. We talked about team culture, we talked about process, we talked about how to communicate, how the attitude of the people. Is that intended? I mean, are you implying that if you have good culture, good team, good process, then good sustainable architecture will result?
Yeah, kind of. I think it's closely related. I mentioned the Aborigines, and an attitude like I'm the big boss and I know what I do here and I'm the hacker, I crank miles of code within an hour, are just not appropriate. They will not lead to something that can be developed in a team and that can be continued in a team. It is related to attitude at least, and maybe a bit about process as well.
I'd say, I think perhaps the first observation, and this is going to come as a big surprise to a lot of people, is that people involved in software development, you know what? They're human beings as well. Really?
Most of them.
Most of them, yeah. So the notion there is that a lot of the standard activities of human beings apply. So yes, we have, in that sense, talked around the notion of culture, of groups, of dynamics, of communication, of process. And let's see how that relates. The metaphor of architecture that we import into software development. Let's go back and see what else architecture defines in the world of the built environment. Architecture defines a quality of what it's like to live somewhere. It tells you about what it feels like to live somewhere. It tells you about the kind of care that you might want to take. It's talking about the habitability of the environment in which you live. Now, all of this applies directly to the notions that we're interested in terms of software. Just as we have the Churchill quote, first we make our buildings, then our buildings make us. In that sense, we are looking at. It's a quote we have in the book, Patent Law into Software Architecture. It's a good book.
That part I don't remember.
You don't remember that part? You need to reread it.
Other problems related to software developers, we build software like cathedrals. First we build them and then we pray. So, in this sense, what we're looking at is the idea that if you're creating the right environment, it's not going to guarantee a sustainable software architecture, but what you want to do is create something that is sympathetic to that encourages that kind of thinking. The attitude, Klaus just mentioned attitude, is very, very important. It's the idea of a kind of a yes we can approach to software, in the sense of, it's very topical, let's just locate this as being the week after the Obama inauguration, for those of you listening in web time. So the notion of the attitude of, yes, software can genuinely be soft. Yes, in theory, we should be able to change it. It is entirely reasonable that we can do these things. Whereas in many projects, there is a sense where the individuals are do not feel that is possible. They do not feel there's a lack of communication with the architect, as Klaus outlined earlier on. If you have the only unification on a team is that everybody hates an architect, that is not going to lead to a sustainable architecture. If you have the idea that, yes, this is possible, we should make this change, yes, we can make this change, and we will make this change because it feels appropriate at this point in time. If that's seen as a possibility, you have won half the battle. Then we get into talking about the technical aspects, which is what encourages these things, which takes us into the code space. How do we organize the code? But very much this idea of the code will reflect something about the organization and beliefs around it. It is very different. You can often tell this when you look at an organization's code. You look at the code and you can tell things about what the organization values and how they push their projects forward. The degree of ritual, the degree of chaos, all of these things are actually visible in the code. Sometimes people are surprised at this. This isn't reading tea leaves. This is a case of archaeology. How do people live? By judging the artifacts that they leave behind. But in this case, we're looking at something more anthropological. The system is hopefully still alive, and so are the developers. We are able to do something about it. It's not the Romans in this case. So we then move on to the technical aspects. An important factor in the entire process, and it goes into company culture as well. So we've just been to the keynote of Tom DeMarco, who really cares about corporate culture. And one aspect of sustainability comes from within the agile movement, and it is about option space. Option space is like the possibilities that I still have open, where I still can move to if I want to. In many organizations, developers and software architects alike feel like pressed to do decisions, because decision-making is a good thing, and clarifying things upfront is a good thing. And sustainable software architecture is really about knowing when to do which decision. Because there are many decisions you need to do upfront, right? But there are many, many decisions that you needn't do early on. Mm-hmm. And you are really better off if you do not decide them.
Well, this is quite important. We see these ideas articulated particularly in lean software development and some of the real options work that's going on. And it runs, again, counter to what many people have as their attitude or belief. As Klaus said, people are making, we value decisions. It doesn't matter whether they're right or wrong, but make a decision. Whereas actually the things of value is looking at the options. Don't give me one option. I often find this when I'm talking to developers. It's like, okay, so you've given me one solution and they're very proud. Now, what about 2 or 3 others? Well, we've already given you one. Well, no, outline 2 or 3 other alternatives. But why would we want to do that? Well, let's just see what the space looks like. Let's see what we could explore. It allows us to explore the criticality of a decision. Well, if we did this would be more open to change, but more complex to develop. If we did that, that's open to change, but not very hard to develop. So maybe we should entertain that. It's the idea of being able to always see the options, the future, rather than as a single track. We are looking at the future as a sort of forking road with lots of options available to us, and therefore we're looking at balancing these options. This is very different to the idea that people value a single item at a time. And this is very much a matter of attitude, and I have found that with a couple of developers in the past where we've outlined the notion of alternative designs, and very much this comes from work in patterns, where explored alternative variations, and the developers have been upset and annoyed. They've been upset and annoyed because I've given them more than one choice. They wanted everything to be predetermined. But this is not an exclusive realm of, say, novice developers. I've had this with architects as well. They do not want uncertainty. They do not want this exploration of design possibilities. And it's exactly this notion of design possibilities and exploring that space that gives us the sense of how to work with this future that is uncertain and untold. Okay, we have a number of options on the table. What is the last responsible moment at which we need to commit to a decision, because this is a significant decision? Or what would we need to know in order to make that critical decision? Therefore, that tells us what we should be exploring, either technically or otherwise. Let's go back to the customer and find out product alternatives. What other paths do they have in mind that they haven't revealed to us? So we're looking at these various different possibilities, and it's very much a very open space in this sense, which is runs counter to linear project cultures.
So we've talked quite a bit about process, culture, and soft issues. So we should maybe go on a little bit to the more technical side.
All right, we're going to talk curly brackets now. Cool.
No, not that bad. No, I mean, which properties of an architecture do we need to track? Do we need to make explicit? How can we do something about the assets we build to make them more sustainable? Or is it all about process? I guess not.
No, it's not. I mean, there is a cycle between the two that plays between the two, and the aspect that the word you just mentioned, asset, I think is a very important one. Yeah. And so, first of all, there's this idea of evaluating your software and looking at it from the point of view of assets. An asset is something that has durable value. And is of value in itself in some way to your business. And being able to assess that, we really want to look at the technical properties of things. What should we make explicit? What should we sort of make visible? There are some very simple properties. Let's start with one of the classics that people focus on, dependency management. In terms of intercomponent and intra-class.
You have components, so that's maybe the first thing.
Okay, so yeah, let me clarify that. I'm going to use component with a little c.
No, I know, but still, you have to have those.
You mean it's not just a big slab called main?
It's not a big spaghetti monolithic.
What, like the system that I referred to earlier that my boss had written?
Yeah,
that's
exactly.
that one. So there is a very simple notion there that you have some kind of that your system expresses some kind of partitioning, that there is something in it. Classes, larger components with a big C this time, layering and such aspects. You're looking at those you're looking at those kind of partitions. Now, first of all, can you see partitions? If you can't see partitions, that's your first warning sign. This is bad. What you have is a slab of code. It might be a sort of obscure surrealist form of poetry, but it's not sustainable. The next thing is to look at the partitioning. A partitioning just simply separates two elements. The next thing is you care about the qualities of that partitioning. What are those qualities? And this is where we start getting into things, the good old-fashioned classic properties of cohesion and coupling. Right. And we start looking at things like cyclic dependencies. Does our system have an apparent layering? If it has, or does it have an aspiring layering? An aspiring layering is where an architect draws up a layered diagram, often in PowerPoint, but sometimes on a whiteboard, and it wants to be layered because they've shown the layers. But when you look at the code, what you see is that it's not truly layered, that you have cyclic relationships between the layering. As such, that system is partitioned, but it is not layered. Layering suggests that there is a strict direction to the dependency, and the direction is down.
Kevlin, what you are doing is you are describing architecture with a big A, with a capital A. Because now you're talking about all the virtues of software architecture, and nothing of this is particularly sustainable.
No, I'm getting to that. Because the notion there is why do these properties actually matter? And this is one of the dirty little secrets. So back to your question about soft skills and all the soft stuff. Actually, yeah, it's all about the soft stuff. It turns out, again, another one of those big surprises, that your processor doesn't actually care about how well partitioned your code is. When your code is run, it doesn't actually matter how well you have named your classes, your methods, and things like that. It does not actually matter the structure of your classes, the layering structure, the cyclic dependencies that you may have between packages are not apparent at the instruction level. So the point there is that the only reason we care about these qualities, and the only reason we have these debates in software engineering, is because they matter to people. The coupling and cohesion are not for computers. Coupling and cohesion are properties that people are interested in. You break things out in a way that gives them a single responsibility. Code does not care about responsibilities. People do. It makes it easier for me to understand. Why do I care about good names? For the same reason I care about cohesion. So the only reason that we have these debates about cohesion and coupling, and this is an important thing, is it's nothing to do with software. There's no mathematical purity here. The reason we do it is purely cognitive. If we were creatures with a very different model of cognition, we would end up with a completely different model of software development. So, yeah, it's kind of all about the soft stuff, but expressed with curly brackets. So that's why those technical properties matter.
Talking about partitioning, yeah, that's right. And I would like to refer back to local decisions that every developer needs to make. And if we look at system properties like performance, these are really critical to a lot of systems. So performance tuning is, in some systems, in the forehead of every developer.
Yeah.
And I know that local decisions, especially performance-related local decisions, can really make a hell out of a system. A mess that cannot be maintained and thus is not sustainable because we cannot develop a second or third version of it. And so what I need to do for the team, me being the architect in this endeavor, is I need to define a place where all performance measures go, so that nobody feels worried that it's not being addressed. And people start addressing it themselves at every opportunity they find. And packaging can lead to that. Layering can lead to that. So if I define layers and I have an abstraction layer for a database or for some operating system, for persistence. Persistence is really the best example here. And say, okay, we will do performance tuning in there and not elsewhere. So if you have some object that you need to query, just go to the persistence layer and query. Do it in an ordinary fashion and do not try to optimize at that place. We will optimize within that layer once we find it necessary. But the team needs to trust in the opportunity to do this performance tuning later on.
So they have to actually have a belief. Again, this ties back to the attitude. They also need to have another aspect there that ties into this. There's the belief in the architecture, but there's also a certain understanding about, again, the changeability. Sometimes people will counter, but sometimes you need to tune performance outside of that layer. The approach, the attitude and the technique at the level of the statement level of the code, all the way up to the larger level, is very much the idea that you say, well, we will do this until proven otherwise, until we reach a genuine contradiction that we cannot solve at this level, then we will focus on working at that level. So in other words, what we're saying here is we're not saying that decision about where the tuning of the data access will happen, we're not saying that decision is fixed for all time. What we've identified is not a static property, but a stable property. Something that is stable opens the opportunity for future change. But what you're saying is, yes, it is possible that we will encounter a scenario that is critically bad, or tuning cannot be solved at this level, and then we will reach that decision. In other words, it's about the possibilities of the decisions. We will reach a point and we will empirically demonstrate now is the time to change something, rather than the second guessing within each class.
So in other words, you want things to be consistent, and then if you decide you need to change it, you want to go from one consistent state to another consistent state in an orderly fashion.
Yeah, and it's understood by all parties.
Explicit decision as opposed to stumbling from one thing to another.
Yeah, so there's that notion that you don't suddenly discover that one developer took it upon themselves to do something, and although it was a radical act of heroism, and you suddenly realize actually that's undermined many of the other architectural properties, and that's going to slow down the next release, or it's interfering with somebody else's work, particularly where you're dealing with life cycles where people have got multiple branches, and suddenly they try to merge them, and you end up with not just a kind of copy and paste issue. You've actually got a conflict of decisions that have turned out to be architectural. They are significant decisions, even though they've been taken at the micro level of the code.
You talked about discovering, you talked about performance measurements. To me, it seems like the act of measuring or discovering or checking or monitoring some of those properties we talked about is kind of crucial. Otherwise, you don't know where you are. So how important is it to check, or whatever you call this, an architecture, to know where you stand? How do you do this? Do you need to do this?
Yeah, yes. So if you look at the real physical buildings that are architected, they also need to know where they stand and whether something is going wrong while they are built. And those buildings that have been adapted during their growth are sometimes the most famous ones. So like the Campanile in Pisa. So yes, it's necessary to measure where you stand. The real issue is, what actually do you measure?
Yeah. I mean, that's what I'm asking.
It's fairly simple. It's fairly simple to measure dependencies among packages and components.
Yeah.
So this is the no-brainer.
Yeah. But that doesn't give you any, performance, dynamic, dependency, behavior, deadlock, blah 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 stuff.
I think one of the aspects is, first of all, there's no one fixed answer. But the danger here is that, so let's talk about what not to measure, or how you know when you're not measuring the right thing. One of the problems is this kind of failure mode of pursuit of numbers. So in other words, people start pursuing every metric available.
Yeah, and then they're overwhelmed.
Just because I can measure it doesn't mean that I need to necessarily measure it or need to retain it. And at that point, they become overwhelmed. And we know a lot about, these days it's easier to talk about being overwhelmed than it was, say, a decade and a half ago, because we just talk about things like spam. Spam.
Oh, yeah.
So in other words, you have, as it were, data spam. This is informational spam. It becomes very difficult to assess the situation. Somebody's tracking so many numbers, they actually miss the real trends. So we could take a very different point of view, which is a problem-focused one. A very simple idea of, let us identify things that are problems. If you identify something that is a problem, what characterizes that problem? So let us just say that if we have a development life cycle that is reasonably rhythmic, it's got lots of opportunities for feedback. If you have that kind of life cycle, then you immediately throw up the problems, whether through retrospectives, very much done by people, or whether you're actually looking at recurring performance problems, or the fact is, we always seem to spend our time tuning things. That in itself is interesting. Okay, well, let's try and see what characteristics the system structure has that seem to correlate with that. So go out and find the things that seem to be causing you the pain, focus on those, find the numbers that seem to correlate in some way with that, and pursue those until they change in an appropriate way. This means that we don't always end up with a fixed set of metrics. It does mean that the metrics that we are looking at, or the measures we are looking at more broadly, the observations that we make, are very much focused, they're opportunistic. We are trying to solve a particular problem. So rather than walking in with 50 individual data points, we are focused on maybe kind of like what I sometimes refer to the metrics of the month. This month, we are going to focus on this area. This seems to be a recurring problem, so we're going to look at that. But it's identifying these recurrences and then allowing you to focus. What can we then measure? And so it's very much, again, it's to do with the cognition, right-sizing it for our mind. Let's go and find things that seem to be causing us problems. Yes, every time we change this, so a very simple one would be to look at correlation of changes. So for each requirement, let us understand what the scatter of change is. So therefore, when you look at this, you sort of say, that's interesting. That requirement, to implement this requirement in say, the product backlog, we have ended up with a scattering of changes across the system. This change involved a large span of change. So clearly the change was not located in one particular thing. We would like an architecture that somehow sort of contains this change. This is what the purpose of partitioning is. So that's a warning sign in that sense. If we have a recurring theme of changes are scattered over the whole system rather than localized, it obviously means that our architecture is failing with respect to localizing change. So watching these various trends becomes a very, very important aspect.
When we come to measuring and what an architect needs to measure, it is definitely helpful to have an early integration of the entire system, to have it running and to be able to do like performance measurements. But talking about sustainable architecture, I would like to ask whether we would like to measure at all.
Okay.
So, or what would we like to measure? So first thing is about metrics, they shape the mind of all participants that have a look at these metrics. So sometimes when I do some metrics, I never tell anybody because I do not want to influence the system. So this is when I have no problem yet. The other thing is it's always most interesting which components change more frequently than others because those are the parts that I consider unstable. And so we can check like how many versions have been checked in. But rather than doing this metric, I find it more helpful to introduce rules that allow change and that keep the cost of change under control. I'll give you an example. We had a large team that was set together from different teams. And while there were different teams, there were interfaces that had to be stable because they were different teams, they had a contract, and changing this contract was so expensive that nobody ever did. When we managed to make this one team and focus on integration instead of deliveries, we also managed to introduce a new change policy that was, whenever somebody changes something, he is also responsible to make the system run again, no matter what parts of the code you need to touch for that. So we omitted code ownership in this respect, and we found a stabilizing mechanism, like, yes, it was okay to change. And everybody had the decision in his hands whether he wanted something to change or not. He just had to make it run. And so suddenly it became a great responsibility to the engineers in saying, okay, this hurts so badly, I go through 30 classes now and change this. Or not. Or not. Yeah.
So I think with that, there is an element there, it's a very important point, and one of the reasons I favour this idea of the metrics of the month. First of all, don't become wed to the metrics. But Klaus also said that sometimes choosing a metric can change the way people respond, and that's exactly the reason you have this kind of approach, sometimes of nominating something. Pick something that people will respond to. Don't pick things that they won't respond to. Don't pick things that they keep seeing every week and have done for the last 12 months because they become invisible. Maybe you have these items that have been in your inbox for the last year. Yeah, they become invisible after a while. And so the idea is that sometimes you choose carefully something that the only way you can change it, you respond to it, the only way you can change it is by improving some aspect. So there is this very careful game. It's a very important one. People are influenced, and that can be used positively as well as negatively. But again, there's also the deeper reading, and this is where we end up with this notion that the danger, the problems of this kind of approach, is to be able to read a situation appropriately. So if I spot that a particular component has a high defect density. So if I look at a particular component, it has a high defect density. We go through the change history, and we understand it has a very high defect density. Now, the normal way that people will read that is it's buggy. The code itself is not well written. Therefore, we have a problem here. The deeper reading and the more appropriate reading is to say what 3 or 4 possibilities might lead to this. One is the code sucks. That's why it's buggy. In other words, it is genuinely bad and was not well written in itself. Another reading is that this component is heavily used by other components. So we find in that case that actually the other components have just as many potential bugs, but it's that they're not exercised as much. In other words, the simple reason we have found so many bugs is this is so heavily dependent upon. The defect density is actually the same elsewhere, but we have yet to discover it. But the third reading, and the one that is the most subtle and hardest to see, but is also often the case, is that that component is using another component whose interfaces are difficult to use. And therefore, they encourage bugs because they create tedious and error-prone interfaces. We see this history with buffer overruns and things like that use certain C libraries. It's not the code that's calling it that is badly written, although it has problems. It is the interface that has caused the problem. So therefore, the problem is not where you thought it was. The defect density is a pointer to the real problem. The problem is not where the defects occurred, it is what they were using in this other component that we have no control over. So it's that recognition that when we are looking at these numbers, we need to do something that is a little bit deeper than just read the numbers and take the first interpretation. The sustainable approach is to re-embrace the component partitioning and change that, not just to rewrite the code.
We have a question.
Yeah, so concerning the sustainable of architectures, I mean, what I'm wondering is, can I even answer it on that level? Because the sustainable, the architecture is okay for a certain case, but it might be totally bad for a different one, and we obviously don't know what's coming. So the question is, should we think about something else? I mean, should we think about the sustainability on a different level than the architecture itself? Should we care about other things? And obviously, a sort of analog to that is the changeability of code. It's not related to the code itself so much. It depends on whether you have good test coverage or not. Because if you change the code and your test break, you obviously know that something is wrong, and you can be sure that it will be found by the tests if you have good coverage, and therefore you will easily change the code, while otherwise with bad coverage the code is not so changeable because, nobody will tell you whether you broke anything. So I'm sort of wondering whether even the title of the whole discussion should be changed to something else, but I don't know what it could be. So
I
what
don't
do you
see
think?
there being a contradiction, because as far as I'm concerned, the code is part of the architecture. If you have no code, you have no architecture. When you were referring to the broader sustainability, I thought you were going to talk about the business case. As far as I'm concerned, if you do not have... Okay, let's deal with a potential contradiction. Can you have a sustainable architecture with unsustainable code?
Yeah, obviously not. But that's not the point. The question is, so I have a system there, and I look at the architecture through some metrics, as you just discussed, and then I go out there as a consultant and say, well, this is obviously sustainable. I think you can't do that, because next day the business guy comes through the door and says, well, look, here is a new requirement, and your architecture all of a sudden should be changed completely. So the bottom line would probably be there is no thing as a sustainable architecture. There is something else that we have to think about to get sustainable systems that we can still develop without exceeding costs and lots of money thrown at the project. So, and the question is, what might that be? I mean, is that really on the architecture level? Is it on a different level?
That is the architecture. It is the set of decisions that the business can invest in. From the business point of view, if we look at it from the business point of view, what is it that will endure? Marcus earlier on used the term asset. And that's quite a valuable one. There is more to this than just the architectural side, but I would say that the sustainability aspect is still key. The set of decisions that you are making in terms of the development is still critical. You're right, a business decision can come along tomorrow that is a black swan. It's just out of nowhere, and it invalidates our assumption. That does not necessarily contradict what we said. We said this is open to change. For business as usual, for a particular set of trends, I think we can identify something that is sustainable architecture, because we are looking at, everything we've said so far is very much about looking at our changes over time. So it's very difficult on day one to create a sustainable architecture. It is easier 2 years down the line to then say, yes, we have created a sustainable architecture.
So you can only judge in retrospect.
Exactly. But there are things that we can put into play that improve the odds. It's a game of probabilities.
If you look a bit beyond the technical systems, and this is what you do when you do an architecture review. So you look at the organization, you look at the team, and if you then introduce sustainability, I would say you have reached a sustainable organization if the organization considers the team as one of the deliverables of the project. That is more than just the architecture, it's also the team that lives the architecture.
And it ties back into where we started very much in that sense. As the architecture, we started talking about the people, the process, and we also talked about this idea of architecture defining a place where these people actually work and live in that sense. It kind of is architecture, but it's a bit beyond the classes.
Hi, my name is Martin. I have a question. You talked a lot about these adaptability, changeability over time, and being as flexible as possible is a good thing to adapt
we didn't say
in
that.
the future.
We didn't say being as flexible. We actually contradicted that. We said being as flexible as possible is not a good thing.
It's not a good thing.
No, not
because
of itself.
You do not need anything about the future. So you need to be flexible somehow. You need
Somehow,
to adapt and change.
Yeah.
So my question would be, isn't it, if you think about the architecture, the thing that it's very costly to change, wouldn't be the best system a system without an architecture?
That's an architecture.
That's not, have no architecture is an architecture.
Let's go back. What the definition of architecture that we gave is the set of significant design decisions. If you are able to come up with a major system that has no significant design decisions,
I think
it's probably not a significant system.
I thought that's a nice point, but I thought that the architecture is not the set of significant design decisions, but the set of significant design decisions that are costly to change.
No. Significant is the definition of.
Yeah.
That's the definition of significant.
Okay.
Yeah. Significant. It actually says the Grady Booch quote is along the lines of architecture is the set of significant design decisions where significant is the cost of change. So if you can design, that's what we mean by significance. It's the criticality, the reversibility of decisions. This is where we're talking about. So if you can create, as Klaus said, it becomes an insignificant system. All systems have an architecture, whether you intended to or not. The question is it an understood architecture, or is it a misunderstood architecture, or is it not understood at all? Is it an explicit architecture? In other words, is it a shared vision? Or is it just something that is tacit and in the background of people's minds? These are the questions we need to ask. But there will be an architecture. Okay, but then I think I don't understand the difference between design decisions and significant design decisions, because I have small design decisions, big design decisions, whatever. And if design decisions are changeable over time, and I think they need to be changeable over time because we have to adapt to changes in the future, and that's a basic thing. I think that all design decisions need to be changeable for the future. No, yeah, that's fine. They could in principle, but let's actually just go to a very simple thing. Let's just pretend. Okay, let's just pretend we're Microsoft. Okay, for a moment. Can we do that? Is that okay? Whoa. Okay, I'm going to invoke the dark side here. Oops, this is going out on SE Radio. Well, there you go. Okay, so let's just imagine that we're Microsoft, okay? And we've got the Windows API. The Windows API dates back a number of years. It uses a particular naming convention, Hungarian naming convention, which is, has generally been deemed a bad idea.
It's hard to learn.
It's hard to learn, and it's also a slight insult to 10 million native Hungarian speakers. But we're going to come to the next question. is a name, is an identifier in code, is that architectural or not? And I always ask people this, and everybody says, oh, naming variables is not architectural. Oh, I say, okay, so how easy would it be for Microsoft to change the names in their API? How much would that cost? Has anybody got any rough ideas? If Microsoft changed the naming conventions in their APIs, how much would that actually cost to change all of the dependent code? Are we talking billions or trillions here? So, do you understand what I mean by significant now, as opposed to changing the name of a local variable? That's what we're talking about, is that all design decisions, in principle, are reversible because it is software. It's not physical in that sense. But they have a different degree of magnitude. If it's local to the team, if it's internal, we can do something about it. But I cannot just simply click on a refactoring menu and say, you know what, I'd like to extract interface from that class over there that Sun wrote, and then suddenly all the code in the world will go. So that's what we mean by significance. How significant have we made the design decisions that we need to be able to flex and change? So that's what we're interested in. I hope that makes it a little bit clearer, that there is this difference of degree.
But this is also where dependency management really plays an important role. Because even within the classes of our own system, we can judge how expensive change will be once we touch the design of an interface.
I agree completely.
Good.
For me, yeah.
So we are Microsoft. Yeah. Oh, no, that's not what you agree with.
Oh, please not. For me, that would lead to not designing systems out of big fundamentals, big architectures, big application frameworks, or big Windows API, for example, instead of moving towards combining systems out of very, very small frameworks, which I can easily change. Right. So that maybe my system becomes a set of very, very, very small things that are easy to change with very small designs instead of one big design, because I can change the small design step by step or easily without very costly things. Maybe I still have an architecture.
Now, yes, you have. What you just described there was What you just described there was an architecture. You told me how you were going to make the decisions in your system. You told me the style of partitioning, the properties that you valued. That is, you have just defined an architectural approach. I hate to say it, but you've done it. Well done. It's a good one. I like it. Does it cost anything? Can we have it? But what you've done is you've actually, that idea of the shared belief, the culture, architecture, the idea of architecture in some societies is very much the way we build things here. That's how we do stuff. That's the vision that's shared by the team. What you've articulated is a very clear vision, and is a very, it's not just clear, it's a nice vision. We like it. So therefore, what you've got there, I mean, it may not be something we can use in all cases, but it is clearly an architectural vision, and you will be able to see when somebody had contradicted it. You'll be able to look at the code.
Thank you.
A pleasure.
So I'm somehow missing the odd, unlike child of documentation here. You were relating to the image of the forked road in the solution space, and I wonder why in this mind map or in your discussion nobody told anything about the look back, why we chose a decision for whatever reasons at a given point in time. So where does the information come from if I can change a decision or not?
Okay, so where have we got it? We've got it somewhere. Oh, here we go. If I look at this mind map, we have a nice little one there of dependency management. There's an implicit, explicit notion there. There is a couple of other notions.
Kevlin, so what about documentation?
No, it's okay. We haven't excluded documentation. If you like the notion, we haven't said...
Let me extend this to
documentation is not a separate thing. I hope it's not a separate thing. I don't want a little branch off here that says, and documentation. Because exactly what we have, it's a bit... Let's put it this way. The way that documentation normally gets treated is, here are all the properties of the system, and documentation. That is the surest way of getting it wrong.
Yes,
I think what you're suggesting...
I perfectly agree. Where I'm leading is, how do you do the traceability? How do you technically implement that?
you record. And a document is a potential way of doing that. So okay, so there's we're not going to isolate this at just the level of documentation. So documentation can be a written thing. Okay, it can also be a photographed thing or other use of other images. There are other ways of visualizing software structures. So sometimes what people will try to do, in fact, I know somebody did this a few years ago, what they looked at was visualization of the trends in the system. And then you could annotate so in other words, it's a historical looking back, and then annotate this is why this was taken here, there, and everywhere. That's much richer than what normally people mean by documentation. Somebody made a suggestion at a conference that I was at a couple of years ago where they talked about trying to track the significant decisions. And one of the ways of doing this is rather than writing it down, what they did is they used a video camera with a system architect.
Or have a blog.
And they had a very simple idea. It was just a case of the whiteboard talk that the architect would normally give to other people was actually recorded. Instead of saying, well, that's great, now could you write it down? It's actually, no, let's actually take the richness of that presentation. And they worked out it was actually cheaper to do, even if it took 4 takes for a 60-minute recording, that's still done in half a day compared to the fact that the architect would probably spend weeks writing it. So I think you've hit on a very good point, but I think documentation is actually a very narrow view of the recording space in that sense.
Yes,
and I think it's very
agree.
important to capture the broader history in that sense.
I just wanted to have the question answered. Where do you get the information looking back? When did we make this decision, and can we revoke that or can't we?
Okay, here is something we do in our projects. We maintain a wiki where we do all the decisions that affect multiple projects, which is those decisions that we consider important as of today, because the system is running, it's out in the market, and so on. So we do some maintenance, and we do still do important decisions there. And actually, when we find ourselves raising some topic again and again every other week, we know, well, this is a decision that we have made, but we were not ready to do it yet. And other decisions were just right. And we find them documented in our wiki, but we do not track them. So we use this wiki to document our decision in some way that everybody who has at least participated in those meetings knows what we're talking about. There is some reasoning included, but we do not track back. And my question would be, why would we need to track back?
So, we're coming closer to the end. Something I was wondering about during all the discussion here is it sustainable architecture or is it sustainable architecting? Because about 70 or 80% of the stuff we talked about was not about how the software is structured, what are good architectural properties, like, I don't know, plugins or whatever. Mm-hmm. It's really about how do you organize the way of finding the architecture, of documenting it, of tracing it, of changing it, and also not just architecture, but also the implementation of the software to make it sustainable.
Right, and the keywords in the title of the sessions are sustainable and software. It's not architecture. So we could as well have called it sustainable software development.
Or just sustainable software.
And just have the same discussion. But sustainable software more refers to the product, but it's about the process of creating the software.
Okay. But there is another aspect to that, is that the term architecture is not simply a description. This is one of those you have to go and look at a dictionary kind of things, is that the term architecture is not simply a description of the software as built. Architecture also defines the name of the discipline.
I want to highlight the thing,
I think it's very important. And indeed, some people actually object to the use of architect as a verb, architecting, although I know perfectly respectable books that have had that in their title. But there is the notion that architecture is embracing these things. So it's the discipline view as well as the actual structure view. And yeah, you're right, there is a very important point to distinguish that those are the things that are going on.
Okay, I know it's risky to ask you to come up with a closing word, because I'm going to ask Klaus for the obvious reason that it's going to be shorter. So, sorry.
What are you saying, Mark?
So what is it that you want to leave our audience, listeners with now that we come to the close of the thing?
I would like to encourage the audience, because everything that we did sounds scary. we said, well, you need to leave the option space large. You need to know when decisions to take when. You need to know what effects that coders implement will lead to disaster or not. And everything about this culture, it's really scary. So how do you know what to do?
Right. You need the
and
looking glass.
Yeah. First thing is, it takes experience. Yeah. The second thing is, this is one of my key metaphors for the way I like to architect. That is, I do not buy into buildings. This is not the correct analogy. I like the medical metaphor. So I'm kind of a doctor then. When the system is up and running, and the team is up and running, we still do important decisions, but we do them when something is found to be ill.
Yeah.
And this is when to step in. And you will know.
So that's also why you wrote those patterns that diagnose, this metaphor about diagnosing.
Still, you need a lot of experience. Yeah. And if you talk really about medicine, there are thousands of years of documented experience that we do not have readily available yet.
So if you manage to go below 1 minute, then you, I think, should.
Do I win a special award?
Yeah.
Okay.
Yeah.
What Klaus said.
Okay. Very good. So, thanks.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.